Okay. Hi again, everybody. All right, just to introduce our next session, it's Power Technology, and our speaker is up here now, William Brown. Welcome, William. Thanks for joining us. Solutions Architect at Power Technology. Principles to successfully combine operations and distribution digital transformation technologies into a one-platform approach for the chemical industry.
Good job, well done.
Yeah? Great stuff. All right, I'll let you go ahead. Thanks very much.
Hello everyone, can you hear me? Hello. Yes, you can. Yeah, you can all hear me. Super. Well, thanks for having me along. First of all, thank you for my introduction. My name's Will, and I've got the incredibly long title here that I'm going to break down for you. So, what a ridiculously long title. How are we going to break that down? We're going to break it down into a few areas. We're going to talk about operational digital transformation technologies. We're going to talk about distribution digital transformation technologies, how we combine those two things together, one platform, and then maybe there's a chance for some questions at the end. This is going to get a little architecture-y and maybe some hardware focus. Please feel free to kind of pipe up if you've got some questions. I'm happy to have some interaction from the audience. I might ask you a few questions about data at some point as well. Okay, so operations. What do I mean when I'm talking about operations? I think many of you will know these kind of sites. It's a manufacturing site. There's some complexity in the process, so it might be making chemicals, might be mixing product together. There's often on-site controls, processes, lots of people. These things are designed for local control and safety, and they're manufacturing tens of thousands, tons of chemicals every year. What kind of data do we want from these places? Well, we want macro data. We want as much data as we can possibly get from the process typically. We want to know who's dispensing what, where it is, the flows, the levels, the pressures, the temperatures, things that will affect us on a macro scale. Often that information already exists as well. There's probably instrumentation, systems, PLCs. There might be third-party packages that have been delivered to site, some of it integrated, some of it not. And the idea is, can we extract data from them as well? Can we get data without compromising those systems from a security or a data integrity perspective? So that's an operational site. What does this look like in practice? Well, there's a few things I'm going to talk about how we would get data from an operational site. We'd look at existing devices. These are instruments typically, so flow meters, analyzers, level sensors, things that are already plugged into your chemical plant. We're going to try and talk to them at a device level, and we might clone or duplicate that signal. So that might be going off to the SCADA or the DCS or the existing system, but we don't want that in there all the time. That's a bottleneck for us. We want to take that out and be able to do something with it later on. So we've got an existing device interface. We might want a new device. That might be a new sensor, a new level instrument, a new analyzer. So we need some understanding of how that's going to fit in. We need to be able to kind of go, does that fit onto this tank? I'm not sure. Somebody with some mechanical understanding. And then existing systems on site. How do we get data out of them? They're often very data rich, might be hundreds of measurement points, calculated values, things that we really, really want out of them. How do we interface with them? Well, what we would typically look to do is create a sensor gateway, some kind of solution on site that will be able to interface. That might be one, two, multiples, depending on the size of the site. But that would collate and collect all of that data from an operational layer. We'll then use a transmission mechanism to take that data to our platform. And we're collecting that information at a hardware level on the site. But there might also be operational data that we want at a platform or a cloud level. Okay, so think about software now and data packages that exist on sites. There might be existing systems that have been bought from an OEM or a manufacturer that sit there. They might be data rich. They might do an analytics on their instrumentation or their equipment that we want. Sometimes they've got standard industrial data connectors that we can plug into and we can get out. We've also got everyone's favorite, the bespoke reports, the Excel documents that have been created with years and years of site experience and knowledge. There's so much information baked into these. We want to get that out. but they're often not in a standard data format, there's no kind of templatizing them, and there's no way to connect to them. So for this, for the existing system, we want to use a standard API or a standard data connector. For any bespoke reports, we'll develop something customized, a customized data collector. And we'll transfer that data at a platform level. So we've got site level, that we talked about previously, and we've got platform level that we're talking about here. I'm trying to make this really simple. Just use known integration techniques where you can, and develop customizations versions where you need to. If you can use a standard integration technology, do it. So a nice little architecture diagram for you here. I'm a solution architect. I love an architecture. Get that data from those existing systems into one place, or put new systems in place to get that data if you need. And what a surprise, I've drawn an architecture. So we're in the operational site, we've collected that data. We've also got distribution sites out there in the world. These are very often remote. They might not be under your control. They could be a third-party site that you're a supplier to. Could be a customer's site. Could be a mix of both. It might be just a delivery point that you've got there. And there might be a small number of measurement points on site that we want to collect. The kind of questions that we're asking ourselves is, what data do we want from them? Well, we want maybe periodic level measurement. We just want to know what's in that tank so we can deliver to it, we can supply to it. Maybe that information already exists. It's a simple sensor, or maybe it doesn't. It's a really, really simple tank or an old tank. So how does this look in practice? It's really, really simple, very similar. We're going to be fitting new devices to tanks out there in the world, to our estate of customer delivery points and customer sites. We might not have an interface to the customer system, so we need to work that out. We might not even have power. So we need to think, how are we going to extract data from something where we've got no power and no connection? We might also want to know, if it's a distribution point on a chemical site, who's dispensing things. So there might be complexity to the system that we're trying to implement there. And then we're going to take that data and we're going to stick it in the platform. The key challenge that we have in the chemical industry is not that the solutions don't exist, because they do. It's getting them done fast and simply and effectively. Those things can definitely be done quickly and easily. It's just getting on with it. So I've combined it all together into one super architecture, for want of a better phrase. But I'm just going to put it simply. Operational sites, collect data from your existing assets. Platform level, transfer that data from existing systems. Distribution sites, collect new data from remote sites, from customers, from silos. Once we've got all of that rich information in one place, what can we do with it? Well, very, very often, all the work that we tend to end up doing is integrating this into business systems. People want data in SAP. People want management level system data. So we need to be able to provide that process level information to management systems. That's not going to come through the DCS. That's going to bottleneck the whole process and really throttle our ability to deploy these things quickly. We need to circumvent that and go around the side. We also want to leave the DCS alone from a security perspective. So we really want to get that deep process level information into those other business systems. Also, when we've got that in a platform out there, we might want to be able to deploy unique analytics. So maybe a distribution delivery driver wants a specific set of data. Maybe a production manager wants a different set of data. But we're using the same pool of data that we've got available to create that. So it's a common truth. It's not two separate systems. So we can create role-based analytics for people. And then we've got all the really clever stuff, you know, the data science, the macro analytics, the big fleet level stuff that I don't pretend to understand. But there are organizations out there that are doing high level analytics across their entire fleet of assets, across production sites globally. Once we've got it into one platform, we can provide data into those spaces. How do I do it? There's a lot of skill sets mentioned here, and you need to have a really deep understanding of instrumentation systems. You need to be able to know how to get data out of something, how to connect an instrument into a process. You need to be flexible in your integration approach. I talked about the Excel document that you've got out there. It's really difficult to develop a standard Excel connector when it's a customized report that somebody built 10 years ago and they've been using ever since. But we want that rich information. We want that knowledge before it's lost. You need somebody with platform level experience, somebody that's able to work on an enterprise level. How do you work not just on one site, but on tens of sites or hundreds of sites? And you need someone that's proven to deliver those things. I hope we fit all those boxes, by the way. That's put on there. And you can come and see us on stand C54. Now I'm going to ask you if you've got any questions. Any questions from anyone? Don't be afraid. Yes, please. I think you'll need a mic. Let me pass it down to you. There we go.
Hi, my name is Peter. I work for ABB. Thanks for the presentation. It was very useful, very all-encompassing platform. But just a question in terms of the deployment mechanism you use, in terms of, because you're taking data from a lot of different sources, a lot of it's going to need contextualized, cleaned through an edge device to eventually get to the cloud and so on.
Yep.
What would be your order of deployment that you'll go about rolling out such a system?
Great question, thank you. Thanks, Peter. So a few points. It depends what we've got already in the instrument. So how contextualized is the data? So let me give you a good example, ABB flow meter, right? It's got to measure flow. It's probably got a totalizer in there. It's probably got a load of different flow rates in there. We might want all of that information. So some of that's already contextualized, and that's really easy to extract. If we're extracting one measurement point, extracting 5 is no harder. So we've got some data and some information there that we've got pre-contextualized. So identify any pre-contextualized information. That would be the first thing. The second thing would be what's simple to contextualize. So is it we're taking a level measurement and we want to infer what dropped out the tank? We need to do some mathematical operation on that. We need to do some work at a cloud level. Might be simple, but maybe a bit more complicated. So simple things first, get data flowing, get some quick context out of it, and work out where you need to develop more context. Does that answer the question?
Yep, thank you.
Super. Anyone else? Please don't be shy.
No? Okay.
Super. I'm on time as well.
Fantastic. That's great.
Thank you very much, everyone.
Thanks so much, William. William Brown there. Thank you very much.